electrons. What are valence electrons?
The outside.
The outer electrons, right? The outer electrons are the valence electrons. So can you tell me, like, this lithium right here has how many valence electrons?
One.
How many?
One.
One, just one. And beryllium has how many?
Two.
Two. So basically the group number, this 1A, 2A, and then this 3A, 4A thing, this matches with how many valence electrons you have, right? So using these numbers, they're going to be very handy when it comes to doing the Lewis structures. So again, if I ask you guys, nitrogen has how many valence electrons?
5.
It has total 7. We understand that, but we don't worry about that number. We worry about this 5. It's in group 5. It has 5 valence electrons. Okay. So what is basically Lewis structure, guys? In Lewis structure, we want to see like how are the individual atoms combined with each other. Okay. So for instance, if you have a molecule called CH4, how is this thing connected? Okay. So basically, I'm going to show you what we actually mean by Lewis structure. So CH4 is bonded like this, like carbon in the center and 4 hydrogens. This is a very simple example. We're going to learn on how we can get the right Lewis structure every time. So for that, we have some rules that we want to learn, and then we'll do some practice, okay? So here you want to be taking again notes, guys. We want to keep this as active as we can, so do not just rely on me writing here. You guys do want to take active notes, okay? It's just better for your learning. Let's go back to our first thing, which is if I ask you to draw Lewis symbol, then Lewis symbol means this, guys. If I ask you to draw Lewis symbol for carbon, guys, tell me how many valence electrons does carbon have?
4.
Carbon has 4 Lewis, so carbon has 4 valence electrons. So when we're talking about Lewis symbol or Lewis structure, we only care about valence electrons. We don't care about total electrons. So if carbon has 4 valence electrons, I need to show 4 electrons on this carbon. And this is how you show electrons, guys. Okay. You can show it like this as well. That does not make any difference. Okay. You'll see how different times it's better to draw it one way than the other. All right. Okay. All right. So this is for, so guys, can you draw the Lewis symbol for oxygen? So draw Lewis symbol for oxygen. So guys, for oxygen, when it comes to Lewis symbol, how many electrons should I draw?
6.
6, because oxygen is 6A, so it has 6 valence electrons. So I draw 6. How do I draw 6, guys? You can draw it any ways you want, like 1, 2, 3, 4, 5, and 6. So you can draw it any ways you want, but this is like one of the acceptable structure, Lewis symbol. Okay?
Okay.
All right. Now, we're going to talk about the Lewis structure. When it comes to Lewis structure, we're talking about Lewis structures of compounds now, okay? So like we're going to talk about CH4. So for CH4, if I ask you to draw the Lewis structure, for this, what you need to do, guys, is there are a few things that you need to do. The first is you count total number of valence electrons. So guys, carbon has how many valence electrons?
4.
Carbon has 4. And then hydrogen has how many? 1. 1. And how many hydrogens do we have? 4. So this is equal to 4. So 4 coming from hydrogen and 4 coming from carbon. So total we have how many?
4.
Total? No, total.
8.
So see, we have 4 from hydrogen. We have 4 from carbon. So if I combine for CH4, it's 8 electrons.
8.
Okay. So this is your very first step of drawing a Lewis structure. Okay. is to first count the total number of valence electrons. All right. Now, the next thing is we need to pick the central atom. Okay. Now, what do we mean by that? Now, you know how I draw the central atom and then I draw 4 hydrogens around it. We already knew this, but for different examples, it's going to be different. What are you going to put in the center? So, who is going to be in the center, guys? These are your rules. The first rule is that the one which is lesser in number will go in center. Okay. And then we have a second rule as well. So if the first rule does not work, what do I mean by it does not work? So if you see if I have 1 carbon and 1 nitrogen, then who is going to go in the center? The one which is less electronegative will go in the center. We'll talk about that right now. Okay, less electronegative goes in center. Okay, now what do we mean by this? Okay, so let's look at another table. I'm going to show you one more table, which has the electronegativities. Where to go? Here. Again, this handout is also uploaded on Canvas, so you want to print this out for yourself. You want to print these out, guys, when you are taking your exam. Let's say, so this is going to be our second exam. So I'll not be able to include these on the question itself because you're only going to have one question at a time on your exam. And so I cannot put this for every question. So you will need to print these out for yourself so that you can use these while you're taking the exam, okay?
You gave it to us on March 5th. It's on the back.
Oh yeah, I think, yeah, so this one I already gave you. Yeah, thanks for remembering me. Thanks for reminding. So yeah, this one I think I give you 2 pages, one on the front, one on the back. So on one of the ones you're gonna find this on the back.
It's on the back of the polyatomic ions.
Yeah, so the back of the polyatomic ion. Thanks, Matt. So the polyatomic ion, you're gonna need this for this first exam, and this table, these 2 tables, you're gonna need them for your second exam 2. So all what I'm covering today, guys, is not gonna be on your upcoming exam, but it's going to be on the second exam. Okay. All right, so now guys, this is the electronegativity table, the one on the top, okay? So what is, you see, it's saying that the electronegativity increases as you go to the right, and electronegativity also increases if you go from bottom to top. So you see these numbers, guys, on all the atoms, like F has 4, oxygen has 3.5, sulfur has 2.5, chlorine has 3. So this is the electronegativity. The bigger the number, the more electronegative it is. And what does electronegative mean, guys? It means that if there are 2 atoms fighting for electron, the one which is more electronegative will be the one who will be attracting the electron more toward itself. So if there are 2 electrons fighting for electron, the more electronegative one wins because it loves the electron more. Okay? Good so far?
Yeah.
Okay. So if I ask you that there's a fight between carbon and oxygen, and they're fighting for electron. So the electron, so carbon puts 1 electron here, and then oxygen puts 1 electron here. You see what I'm showing you guys? These circles that I'm showing you, the tiny dots, these are electrons, okay? So carbon puts 1 electron, oxygen puts 1 electron. That's how you ever make a bond. If 2 atoms are making a bond, guys, in a covalent bond, they're basically putting their electrons in the center, and both the atoms have access to both the electrons. Guys, you want to listen to this part carefully, okay? You have carbon and oxygen. When you make a bond between carbon and oxygen, carbon puts 1 electron, oxygen puts 1 electron. When they both put electrons next to each other, that's what makes a bond. So for making 1 bond, how many electrons do you need?
2.
You need 2 electrons. Okay?
2.
Now,
So
am I saying that carbon has lost the electron to the oxygen, or am I saying that oxygen has taken away the electron from the carbon?
No.
No.
No,
You're sharing.
they're sharing because it's a covalent bond, so it's sharing. So when we say that, do you think it's an equal, fair sharing? Is it a fair sharing between carbon and oxygen, or is one more stronger than the other?
Stronger.
One is stronger. Who is stronger based off this table? Can you tell me? Carbon is 2.5, oxygen is 3.5. Which one looks more stronger to you?
Oxygen.
Oxygen.
So what is oxygen doing, guys? Oxygen is doing this. So I'm going to show this with an arrow, okay? Carbon is actually, oxygen is actually pulling the electron more towards itself away from the carbon. I'm not saying that oxygen is taking away the electron from carbon. It's just pulling it more towards itself. Does that make sense, guys?
Yeah.
Now, what is the charge of electron? What's the charge of electron, guys?
Negative.
Charge of electron is negative. So if oxygen is pulling the electron more towards itself, again, I'm not saying it's taking away the electron. If it was actually gaining the carbon's electron, then oxygen will become -1. But that is not happening here. It becomes partially negative. Okay. So guys, look here again, okay? When I'm saying oxygen is pulling the electron away from the carbon, oxygen is becoming a little more negative, okay? I'm not saying it's becoming very negative. I'm just saying it's becoming partially negative, okay?
This
This
one
is
have
a
to do
symbol for partial.
completing the 8.
What's that?
Does this have to do with completing the 8 or?
No. This is a symbol for partial.
Oh no, but I'm just saying. Does this have to do with oxygen wanting to complete its valence shell?
Right. That's a reason why it's more electronegative. Yes, because oxygen already has 6 electrons and it only needs 2 more, so it has this intrinsic tendency to love its electron more than somebody who has to gain like 7 electrons to become 8. Okay. Right. Any more questions, guys?
So you said that's not an 8, that's a partial sign?
Yeah, that's not a 8. That's a partial sign. It's like it's a small d in Greek. Okay.
Oh yeah, that's simple.
Yeah. Right. Now coming back to our chart. Okay. So where we were learning what to do here. So guys, the first rule was that the one which is lesser number will go in the center, and then if there's a tie, then the one which is less electronegative will go in the center. Now this has an exception, guys. Hydrogen always outside. Okay. Let's come back to this example, CH4. So if I have to pick who is the central atom, guys, so I hope everyone understand what I mean by central atom. I mean this. So if I have to pick the central, if I have total 5 atoms, the one which is lesser number, like you see, this is AX4 is the formula. I'm putting A in the center, and then I'm putting all the X's outside. Why? Because I have 4X and I have 1A. So the one which is lesser number, which is A, will go in the center. And then the ones which are more, like X, are the ones which are going outside. That makes sense, guys?
Yes.
Okay. Now for CH4, can you tell me who will go in the center in this case?
Carbon.
Carbon.
So carbon should go in the center, right? Because there's just one carbon. So when you're able to decide from the first rule, then you don't have to worry about the second rule, which is the less electronegative rule. The second rule will only come into play if we had 2 atoms and both were 1 and 1. That's when the second rule comes in. Most of the time, the first rule will help, will do the work. Okay. Now, we have how many hydrogens, guys?
4.
4.
4. So what I'm going to do is I'm just going to draw 4 hydrogens outside. Now, the next thing you need to do, let me actually number these rules, guys. So the first rule was that you did the total. The second rule was that you picked the central atom. The third rule now is use the electrons to make bonds. Okay. Now, guys, can you remind me one bond takes how many electrons?
2.
2 electrons, right? Now, this is 1 electron from hydrogen, 1 from carbon, 1 here, 1 here, 1 here, and 1 here, 1 here, and 1 here. So how many electrons did I use?
8.
8.
You see, 2 plus 2, 4 plus 2, 6 plus 2, 8. I've used 8 electrons, right? So this is where you're going to first spend the electrons. Like, guys, if you when you get your paycheck, you first spend your money in things that are essential, or ideally that's how we should be spending it, right? So we wanna do our needs, not our wants. We wanna take care of our needs first. So the first use of the electron is to make the bond. Okay. Then if we have more, we'll talk about that, what to do with them. Okay. For right now, we use the electrons to make the bonds. How many electrons did we use, guys, right now?
8.
8.
Did we use 8 electrons right now? How many did we have total?
8.
8. You see we have used all?
Yes.
Yes, we have used all, okay? So now, again, guys, when you're showing the bonds, you can show 2 electron as one bond, or you can simply show a line for a bond. I usually prefer showing bonds instead of 2 electrons. It just, I don't know, for me, this line makes more sense for a bond. Although, do you think there's actually a line between 2 atoms when they're bonding? No, it's just, they're just putting their 2 electrons, and that is helping them make that bond, okay? So there's no like stick between 2 atoms which is holding them. They're not like holding each other by any ways. So we have used 8 electrons. Now the very last and important rule for this example, guys, we will have more rules as we do more complex examples, okay? But for right now, the 4th rule, which is the important rule, is called the octet rule. This is the rule of 8. Let me see, guys, maybe somebody trying to contact me. No. Okay, never mind. Okay, so guys, this is a rule of 8. Rule of 8 means that all the atoms, guys, all atoms want to pretend as if they have 8 electrons. Yes, I'm getting some background noise. I think, Sylvia, I'm going to mute you, and then later you can unmute yourself when you have a question, okay?
Okay.
Okay. All right, guys, so what we want is all the atoms want to feel as if they have, don't pretend as if they have 8 electrons, all that they don't. What we just did earlier, guys, we made this, right? This is what we made. Can you count that carbon has how many shared electrons right now? Now, let's see what it means by shared electron, okay? First of all, you know each bond is made up of 2 electrons, 1 here and 1 here?
Yeah.
1 here and 1 here? 1 here and 1 here. You don't have to show these dots. I'm just showing you them right now so that we can do the counting, okay? Okay, so by shared electrons, I mean this. Learn this terminology that I'm going to be using very often, okay? When I say carbon owns how many electrons, you're going to only count these 4 electrons which are sitting next to carbon. Okay, when I say the word this carbon owns how many electrons, it's this electron right here, this electron right here, the 3rd electron right here, and the 4th electron right here, the ones which are right next to the carbon. But when I ask you how many total shared electrons it has, so when I say the word total shared electrons, then guys, you actually include all the electrons that are involved in making the bond for that atom. So what do I mean by that? You see this carbon? It had 4 electrons already. You also count the other 4 electrons that hydrogen is putting in making these bonds. So guys, can you tell me carbon now has how many electrons? How many total shared electrons?
8.
8.
8. So let's count that here, okay? 1, 2. So guys, here on your screen, 1, 2, 3, 4, 5, 6, 7, 8. So we have total 8 electrons now. Okay, so this is what we mean by the octet rule. So when you're talking about octet rule, you don't care about the electrons the atom owns, but the electrons that are total shared. Okay. Now you see, guys, when the carbon has 8 electrons, we say that the octet is good and carbon is happy. That's what it wanted. That's why it's actually making 4 bonds, so that it has this 8 number. Okay. Now, when you're talking about the octet rule, you want to add to your notes that all the atoms, yes, they do want octet, but not the first 5. The first 5 atoms. So the first 5 atoms don't care about octet. Okay, so which ones are the first 5 atoms, guys? Can you name those for me, please?
Hydrogen,
Hydrogen,
helium.
helium, helium.
Right.
Beryllium, boron.
Exactly. So the first 5, right? So it's the hydrogen, helium, lithium, beryllium, and boron. What is special about these guys? Do they care about octet or they don't care about octet?
Don't care.
They don't care about octet, okay? So now, when it comes to CH4, guys, when you draw all the atoms and you're showing all electrons that it had, which were 8 electrons, and you have the octet, then you are done with your structured Lewis structure. That is your final answer. Okay. Now, guys, does this hydrogen care about the octet?
No.
No.
No, it does not, because he states among the first 5, it does not care about octet. Does carbon care about octet?
Yes.
Yes. Does it have 8 electrons shared?
Yes.
Yes.
Yes. So then our structure is good.